Hello students, hope everyone are fine. Okay, in the last class we have studied that what is that which is common in all the acids and bases, right? So we have studied that all the acids contain H plus ions in common and all the bases contains OH minus ions in common. But the problem is that these ions won't be produced if the acid or the base is in dry condition. Dry condition means if it does not contain any water, that is very dry, it won't produce H plus or the OH minus ions. It is the hydrogen ions and the OH minus ions is there in acids or bases, but it will be liberated only if it contains certain water present in it. Okay, so in this video we are going to study the reaction of acid and bases with the water. And one more thing that I need to tell you is that at the end of this video I'll be uploading the notes for today's video. The last class also I didn't give you any extra notes. So for those two classes, the last class and today's class, I'll be uploading the notes at the end of this video. You have to watch the video, you have to write the notes from this video itself, using this video itself. Okay, I hope everyone are completing your notes as well as the record. One experiment we have already covered. Then soon after, sometimes some days I will give you the next experiment also.
Let us now discuss what will happen when an acid or base, mixed with the water solution. So now we can discuss what will happen when an acid or a base will mixed with the water. Okay, in the last class we have studied that all the acids have one ion in common. What is that ion? Yes, all the acids have H plus ions, right? H plus ions. And we have studied that all the bases have OH minus ions in common, right? Hope you remember it. So all the acids contain H plus ions, right? What do all acids and bases have in common? At that time we have studied that all the acids have H plus ions in common and all the bases have OH minus ions in common. But acids or the bases cannot liberate H plus ions or the OH minus ions if it does not contain any water content in it. If there is no water content means it cannot liberate out H plus or the OH minus ions, right? So we can go back to the last class. We have studied that in a beaker, if you are taking the HCl solution, right? We have told that HCl solution, right? When we are taking the HCl solution, then it will conduct electricity, right? Then it will conduct electricity. That is what we have studied in the last class. But here the most important point here is that we have taken HCl solution, not the concentrated HCl. We didn't take the concentrated HCl. Instead, we have taken the solution of HCl. Solution of HCl means HCl and it should contain water. HCl mixed in the water, that we call it as the solution. So it contains water in it. That is why it is liberating, or it is having, or it is giving out the H plus ions. Same thing will form for the bases also. Bases also won't give out the OH minus ions if it does not contains water. Okay. So we can say that the separation of H plus ions or the OH minus ions cannot occur in the absence of water. In the absence of water, separation of H plus or OH minus won't happen. So it won't conduct electricity also. So what should be there? The H plus or the OH minus ions are produced, it will be produced only in the presence of water. So make sure that the solution, it should be in the solution type, right? It should not be dry HCl, or it should not be concentrated HCl, it should be solution of HCl solution, or solution of NaOH. Okay, so let us check what will happen when this is mixing it with the water. Okay, suppose I am taking acid plus water. What will happen when an acid reacts with the water? For example, I have taken the HCl, hydrochloric acid. It is reacting with the water. So when it reacts with the water, what will it will do is, it will liberate out H plus ions. So when the hydrogen is removed, what else is left over here? Right? Cl. So Cl minus also will be formed over here. Again, what will happen means, now we have the water content also is here, right? So this H plus ions, at that time itself, what it will do is, it will react with the H plus ions, will mix with the, here we have the water also, right? It will mix with the water and produce another ion. We call it as, here one hydrogen, here two hydrogen, one oxygen, right? So we'll write it as H3O plus. H3O plus ions will be formed over here. Okay, H3O plus ions, we call it as the hydronium ion. We call it as the hydronium ion, right? Hydronium ion, H3O plus. So we can rewrite this equation. We will write this equation as HCl plus H2O gives, instead of H plus, what we will do? We will write it as H3O plus, because what will happen? H plus, when it is formed, at that moment itself, it will mix with the water. H3O plus plus, what else is here? Cl minus. Okay. So what we have studied now is, when an acid HCl reacts with the water, it will form H plus ions and Cl minus ions. Since this H plus ions, what will do? This H plus ions, it will react with the water to form H3O plus ions. H3O plus ions. So instead of H plus, what we can write is H3O plus. So we'll rewrite this equation as HCl plus H2O gives H3O plus plus Cl minus. Okay, hope you have got it. So we can just look at what will happen when it is reacting base with the water. When a base reacts with the water, what will happen? For example, we can take NaOH. Same type of reaction will be forming. NaOH plus water. NaOH, when it dissolves in the water, what will happen? No, it will liberate out Na plus ions and the OH minus ions. Liberate out Na plus ions and the OH minus ions. For example, KOH, another example, KOH, potassium hydroxide. Potassium hydroxide is another example for base, right? Potassium hydroxide, it will dissolve in the water to form, what else? K plus and OH minus ions. Okay, then magnesium hydroxide, MgOH twice. Instead of writing plus H2O, we can write H2O on the top of the arrow. Okay, so this also indicates that magnesium hydroxide is dissolving in water. Again, what will be the products? Magnesium, Mg2 plus, right? Then we have OH minus ions also. Okay, so 2 OH twice is there, right? So we can write it as 2 OH minus. In order to make it balanced, we can write as 2 OH minus. Now, all the bases, all the bases cannot dissolve in the water. That is a problem with the bases. All the bases cannot dissolve in the water. So only those bases, no, only those bases which are soluble in water. All the bases cannot dissolve in the water to produce the OH minus ions. What we call it as OH minus ions? What is the name of it? Hydroxide ion, right? Hydroxide ion. All the bases cannot liberate out OH minus. All the bases won't be soluble. All the bases won't be soluble in the water. Such bases which are soluble in the water, we call it as the alkalis. We call it as the alkalis. So only those bases which are dissolving in the water, we call it as the alkalis. All bases do not dissolve in water. All the bases do not dissolve in water. So only an alkali, it is a base that is dissolving in the water, and they are bit soapy in feeling, and they are bitter in taste. These are the characteristics of the alkalis, and they are bit corrosive also. They can cause destruction to the other metals. Then we can say that all bases are not alkalis, because all the bases cannot dissolve in the water, but all alkalis are bases, right? This is correct, right? All the bases are not alkalis, because all the bases cannot dissolve in the water, but all the alkalis, it will be surely base itself, because all the bases which are dissolving in the water, we call it as the alkalis. But when we mix an acid or a base in water, so when we mix it, what will happen means the amount of ions present in, ions means H plus ions, or the H plus, instead of H plus we can write a H3O plus ions, or the OH minus ions per unit volume will get decreased, right? So suppose we have one beaker, up to here we have the HCl. Okay, so when we are adding the water, what will happen? The amount of the volume will get increased. So suppose I am taking this much of volume of HCl. I am taking only this much of volume of HCl. So number of, or the amount of H plus ions or the OH minus ions present in a per unit volume will get decreased when we dilute it with the water, right? When we mix it with the water, what will happen means the amount of H plus ions or the OH minus ions will get decreased. We can say that the concentration of the, we can use that term, concentration of H3O plus ions or the OH minus ions will get decreased if we mix it with the water. That process by which we are mixing the acid or a base with the water, we call it as the dilution. Okay, so those acids or the bases which have undergone dilution, we call it as the dilute HCl. That is, if you are diluting the HCl, we say that dilute HCl or dilute NaOH. So if you are mixing with the NaOH, then we call it as the dilute NaOH. Okay, so whenever we are mixing a acid with the water, we call it as a dilute acid. Okay, so if we are diluting a base, then we call it as the dilute base. Okay, dilute base. Okay, so depending upon that, we can we have different categories of acids and bases, so we can study about that now. So depending upon the number of H plus ions or the OH minus, we have concentrated acid and the diluted acid. Then we have strong acid and weak acid. The same thing will be there for the base also. Okay, so we can write it as base. Strong base or a weak base. Okay, now what is this concentrated acid or a base means? Which contains less or no water content in it. If the amount of water is very less or no water at all, then we call it as the concentrated acid. Suppose if you are taking 1 ml of acid, we are taking 1 ml of acid, 1 ml will be the acid itself, there won't be any water content in it. Okay, such type of acids we call it as the concentrated acid. Diluted acid means if it is having more water, then we call such acids or a bases as the diluted one. Okay, it contains more water in it. Suppose if you are taking 1 ml of diluted acids, means it will contain 1 ml means almost it's 90 percentage of it will contain water. It's only a slight, very diluted means it contains only 10 percentage of acid or a base in it. Okay, so that is what we call it as the diluted acid or a base. It will contain lot of water content in it. Okay, we will represent this as the, we won't write fully, we will write concentrated, CONC is enough, then diluted, DIL is enough. So diluted acid, okay, and concentrated acid, this is enough. Now we have another category. So one more time, so concentrated acid will contain more H plus ions or the OH minus ions present in it, right? Now when we are taking a per unit volume, a particular volume of the concentrated acid, it contains more H plus ions or the OH minus ions. But when we consider the diluted one, it will mix with the water. So when we consider per unit volume of a diluted acid, it will contain less H plus ions or the OH minus ions present in it. Okay. Now we have another category, strong acid and a weak acid or a base. Okay, what is meant by strong acid means an acid which can liberate, which can produce more H plus ions, or the OH minus ions, then we call them as the strong acid or a strong base. But those which can produce less H plus ions or the OH minus ions, we call them as the weak acid or a weak base. Okay, HCl is an example for strong acid. It can liberate a lot of H plus ions. H2SO4 is an example for strong acid. It can liberate out the lot of H plus ions. But CH3COOH, what we call it as? It is a acetic acid. Acetic acid is a weak acid because it can liberate out only less H plus ions. Okay, so hope you have understood. Concentrated acid or a base, diluted acid or a base. Concentrated means it contains no water in it or very less amount of water. Diluted acid or a base contains lot of water present in it. Then strong acid means which can produce. It is, we are defining strong acid and strong base in the criteria by which it is producing H plus ions. So if they are producing lot of H plus ions, then we call them as a strong acid. If they are producing less H plus ions, then we call them as the weak acid.
So we have studied that these H plus or the OH minus ions will be produced when we mix the acid or the bases with the water, right? But can we mix acids or the bases like that? Can we mix acids with the water or the bases with the water like that? There is a method by which we can add water to the acid or a base. Otherwise, what will happen means the acid, if you have taken one beaker full of the hydrochloric acid is there, then we are pouring some water into it, means the reaction of acid and the water is really an exothermic reaction. It's a highly explosive reaction. Lot of heat energy will be evolved out. So what will happen is, if you are not careful, you have to be very careful when you are mixing water with the acid. Otherwise, what will happen is enormous amount of heat energy is liberating out. That can even cause that beaker to break. That much of heat energy will be liberated. So there is one method by which we are diluting an acid or a base. Acid is more dangerous, while handling acids are more dangerous. So what we have to do is, don't ever pour water into the acid. Don't ever pour water into the acid. So what you have to do is, you have to take the water in a beaker, then you have to slowly add acid into the water. Okay, water should be there, you have to add slowly acid into the water by continuous stirring. Also, you have to stir it continuously, because as I told you, the mixing of acid and a water is a highly exothermic reaction. Enormous heat energy will be liberated out. So when you are diluting it, you have to be very careful. Otherwise, what will happen is, it can even burst out. It can split on our faces. It can come connect with our faces or the hands. We will get burned. So you have to be very careful while handling. So this question has been asked many times. So when we are mixing water and acid, you have to pour acid slowly into the water with continuous stirring. Why? The reason is that mixing of acid and water is a highly exothermic reaction. So if we pour water directly into the acid, it will burst out. It can even cause the beaker to break out. A lot of heat energy will be liberated out. It can even cause harm for our body also. Okay, so hope you got that point.